what do you need to do when they ask you to find a gradient at a point? Well, the first thing you need to understand is this formula. Gradient is equal to y2 minus y1 x2 minus x1. So we can also call it slope, so that's just it. So you need to know the values for the y2 on the graph, y1 on the graph, x2 and x1 on the graph. Before you can really solve for gradient, there are two important things you need to understand. I brought them out in these formats. We call them the negative gradient and the positive gradient. The negative gradient, obviously, as you look at it, is the opposite form of the positive gradient. Now, you can see it in different forms. For some graphs like this, let me start with the linear graph. For the linear graph, you could have your graph in this format, and then you have to draw a triangle. So most times when you're looking for gradient, you have to draw a triangle to find the points for the y, and x. But if your graph goes this way, then the triangle goes this other way. So that gives you the different types of forms of gradient. So that's exactly what we're talking about. So the negative gradient, where the point where the y1 is and the position of the y2 is different from the position of the y2 and y1 on the positive gradient. So at the point where you have the y1 here and the y2 here, you have it in a different format for the positive gradient, where you have y2 up and y1 down. So these are important things you need to know. Then the x1 and x2 actually stays the same between the two gradients. So the point of gradient is for you to find the slope. So what you need to do when you're looking for gradient is for you to trace the points. After drawing the triangle, you have to trace the points to get to y1. So let's say this is the linear graph. So let's say the point here is 5. Okay, and let's say the point here is 3. I don't know how that possibly, but yeah, let's say the point there is 3. Then for x here is obviously 0, and here could be 4. Okay, so we brought out 4 points here. Like looking at this, obviously this is a positive graph, positive gradient graph. So what we're going to do is we'll notice that here we're going to have here, we'll call this y2. So in your graph, you trace from here to here. So this is your y2. So you could write it down as y2 equals to 5, and then your x2 here, x2 equal to 4. Your y1, this is this down point here. Yeah. So you know it is y1, y2. So trace it down. Then this is x2, is x1, like we gave in the graph. So this is your y2, sorry, this is y2 here, y1. Okay, so your y2 is 5, your y1 now we're just assuming is 3. Okay, then your x1 equal to 0. So just like we mentioned, we're going to put that in this format. We're going to put those values in this format for us to find the slope. So if we have that kind of value, that means we're having y2 minus y1, which will be equal to 5 minus 3 all over x2 minus x1, 4 minus 0, and we're getting 2 over 4. Then we get our answer as 1 over 2. So I'm just giving a kind of draft work on how you can really do it on your own. So for you to know exactly in the different graphs, okay, like this one is this should be a positive gradient. This should be a negative gradient. Now, once you know which is which, then you can easily know where the values for y2 and y1, you can trace it out on the graph. Now, this one obviously is a negative slope, and it changes. The y1 comes up and the y2 comes down. So you have y1 here, y2 here, but x1 remains the same and x2 remains the same. So the idea is for you to be able to trace the y1 to the y-axis, x2 to the x-axis. You bring out the values, you put it in the format of gradient, you trace the x1 and x2, and you solve. Now, what if they ask you to find a gradient at a point? Now, most times that question involves a curve. Now, this is an example of a curve. Now, a quadratic graph involves a curve most times, or normally involves a curve. So they could ask you to find the gradient at a point where x is equal to 3, or a point where x is equal to 4, or something like that. So for you to be able to get at that point, you need to look at your graph. So supposing we have here, obviously 3, then you trace it up and see that maybe it stops at this point here. Then you rule a line and you form a tangent, and then you can also get a triangle like this for you to find the gradient or the slope. So normally in a gradient of a curve, you form a tangent of a particular point at a particular point for you to be able to find the gradient at that point. So this is exactly how it looks like at a different point. So you remember the equation comes out like, what's the gradient at x equals to this? So the gradient at a particular point, that is that's the form the question can come when you ask to find the gradient. Now, if the principle remains the same, if it is in this format, if you rule this way, you definitely form a negative graph, a negative gradient. Then if it is ruled this way, you form a tangent with positive gradient. And then you remember that for the positive gradients, we have y2 up, y1 down. The negative gradient, we have y1, y2, but the x remains the same. So just like we did before, we can still label it so that you understand it when you're doing it. And this is x1, x2, it traces down, this one traces to this point, and this one traces to this point, and you get your slope or gradient as y2 minus y1 over x2 minus x1. So after you trace the values and get each value for them, this is y2, yeah. So this y1, y2, so you get each values, then you put them into this formula and you get your gradient. So the basic secret is for you to be able to know which of them is a negative gradient and which is a positive gradient. And just like we've explained, a negative gradient is always in this format. The positive gradient is always in this format. And the values for y1 and y2 and y2 and y1 are different in the different gradients. But x1 and x2 and the gradients remain the same. So if you know this, you know that y1 for the negative gradient starts it up, and for the positive gradient, y2 starts it up. Then you'll be able to solve that. So that's just the idea about gradients. If you're able to know where each value of the y-axis and each value of the x-axis are, you'll be able to solve any question on gradient. Now remember that for the gradient of a curve, you need to mark the point to form a tangent for you to be able to get the gradient of that curve.